Hello everyone. Let us discuss conditional probability today. So assuming B is an event and A is another event which has already occurred. So in conditional probability, one event already occurs, is known. This expresses probability of B given A is equal to probability of AB by probability A, which has already occurred. So probability of A not equal to 0, and it is expressed as probability of B given A. So joint probability, the conditional probability is equal to the joint probability of AB divided by the probability of A. So probability AB by A means joint probability of AB divided by probability A. Now what is alternative expression? So conditional probability is equal to probability of AB by A, probability A. So if we cross multiply, then probability AB is equal to probability of B given A into probability A. So assuming independent events of conditional probability, so if the events are independent, then conditional probability is equal to probability AB by probability A. It is probability AB means joint probability is equal to probability of A into probability of B if the events are independent. Now if we substitute, then conditional probability is equal to probability A into probability B. So for AB we will substitute probability A into probability B divided by probability A. So if we cancel, is equal to probability B. Now let us have one illustration. Okay. So let a random variable x1 is smokers. Then x2 is male and female. Then total smokers is 60, comprising 40 male and 20 female. Then 40 non-smokers, out of whom 10 are male and 30 are female. So total male is 50 and total female is 50. The grand total is 100. Let A is an event selecting a smoker and B is an event of selecting a male. So smoker, A is selecting a smoker and B is an event selecting a male. So probability of A means smoker. So total smoker 60 divided by grand total 100, and male probability of B 50 male divided by grand total. So probability AB is probability of selecting a smoker who is a male. Out of 40 male smokers. So probability AB is equal to 40 by 100. So probability of B given A, the conditional probability, is equal to probability the male smokers leads to probability of selecting a male given a smoker is selected first. It is probability of B given A is equal to 40 by 60 So probability of B given A is equal to 40 by 60 is equal to 40 by 100 by 60 by 100 is equal to joint probability by probability of A, and probability of A not equal to 0 is a positive. From the definition of conditional probability, probability AB is equal to probability A into probability B given A. Probability of both A and B occurring is equal to the product of the probability of A, probability of A occurring and the probability of B occurring given A has occurred. So this is the A, that probability of AB is equal to probability of A into probability of B given A. So probability of both A and B occurring is equal to the probability of the probability of A occurring and the probability of B occurring given A has already occurred. Okay, this is a set of exhaustive and mutually exclusive hypotheses. B1, B2 and Bn, given that there is a priori probabilities, probability of B1, probability of B2 and probability of B3 so on of the probability Bn. It corresponds to a total absence of knowledge regarding the occurrence of the event A, and conditional probabilities, probability A given B1, probability A given B2 so on, probability A given Bn. So it is required to form the a posteriori probabilities, probability B1 given A, probability B2 given A, and probability Bn given A. So how Bayes' theorem or say Bayes' rules are used in probabilities. Now proof. So using theorem of compound probability, multiplicative rule, say probability ABI is equal to probability BI, probability A given BI. So I stands from 1 to n. So A B1 or A B2 or A B3 and so on, A Bn is equal to probability BI, event BI, and probability of event A given event BI. So this is equal to probability of A into probability of BI given A. So after simplification we get probability of BI given A is equal to probability of BI into probability of A given BI divided by PA. So this divided by this is equal to probability of BI given A. Now in case of mutually exclusive cases, applying the theorem of total probability, so probability of A, event A is equal to probability of event A into B1 plus probability of A B2 plus so on, probability of A Bn. So this can be sum of, this is equal to sum probability Bi into probability A given Bi. So therefore probability Bi given A, probability Bi given A is equal to probability Bi into probability A given B divided by probability, sum of probabilities bi into probability A given bi. So we have got that probability of bi given A is equal to this. So from there we get bi given bi given A is the probability of beta bi into probability of A given B divided by, because divided by PA. Instead of PA, we can write sum this, the posterior probability. If another event C is added, given the probabilities P, C given AB1, probability of C given AB2, that means this is another event. It becomes like this, that the probability of C given A, B, N. So probability C A is equal to sum of this P CBI given A is equal to P given is equal to sum of probability BI given A into probability C given ABI. So after substitution, probability CA is equal to summation probability BI into probability ABI into probability C given ABI divided by summation probability BI into probability A given BI. Okay. So this is all about the use of Bayes theorem in probability. So with this, we thank you. If another event C is added, given the probabilities, probability of C given AB1, probability of C given AB2, and so on, probability of C given ABN. In proof, using theorem of compound probability, probability of ABI, the probability of two events A and B I jointly, is equal to probability of BI then probability of A given B is equal to probability of A, probability of B given A. So then we can find out probability of BI given A. So probability of BI given A is equal to probability of BI, then probability of A given BI divided by P, probability of A. Event A can materialize in a mutually exclusive forms, AB1, AB2, so on up to ABN, applying the theorem of total probability. Now let us see probability of A is equal to probability of AB1 plus probability of AB2 plus so on plus probability of A, B, N. So this is equal to probability Bi into probability A given Bi. Okay. Therefore, probability Bi given A is equal to probability Bi given A is equal to probability Bi into probability A given Bi divided by, so this is the formula, probability of Bi given A is equal to probability of Bi into probability of A given Bi divided by probability of A. But we have found probability of A is this. So this divided by probability Bi into probability A given Bi. So this is posteriority, and probability of Bi is priori probability. So second, probability of Ca is equal to probability Cbi given A is equal to probability P probability of Bi given A and probability C given ABI. So probability of Ca is equal to probability of Bi into probability of A given Bi into probability of C given ABI. So, and denominator is this, probability of Bi and probability of A given Bi. So after substitution, so this is all about Bayes rules. Thank you for watching.